is the homework assignment number 2. The annotation file, old one, so I still use it. Okay, all right. First, question number 15, M expression and N expression. Okay, M in terms of H expression. Second, so that's the first one you need to find. Second one, N in terms of H. All right, yeah. But for the first one, you need to know the structure of the heap. Okay, yeah. The first one, M, is the minimum of the number of elements in a heap of height H. So we know the height is H, starting from root. Yeah, we know when we build a heap, we fill level by level, right? Yeah, but the last level we do not need to fill. Okay, only the last level we do not need to fill. Yeah. Other than the last level, all the other levels must be filled. Okay, so that's the basic heap structure. Now we know, oh no, yeah, we count, you know, yeah, the height. Okay, so this is the height. We count, we start from the root, and we count number of edges until we reach the bottom level, and the longest path, so that's the, you know, height definition. Yeah. So longest, do not get that part wrong. Okay. All right. So longest here for this case, bottom level, 1 node at the bottom level. For case 1 level. All right. So you know there are H edges. Okay. H number of edges for the longest path. Okay, yeah. And the bottom level, only 1 node. Okay, yeah. So with that information, can you figure out the formula M in terms of H? Right? Yeah. So let me give you one more hint to answer this question. One more hint. Okay. All right. That strategy we used a few times before, right? So you can try this strategy. So try some small h. Okay, yeah. For example, h equals 2, 3, 4, right? Yeah. And with these examples, can you find the formula? Yeah. Yeah. I think you can see the rule easily. Okay. Yeah. See some rule easily. After you see those numbers, you can see the rule easily. Okay. All right. Similarly, for case number 2, then I think that will be much easier. All right. Because this time, the maximum N equals maximum number of elements for a heap with height h. Okay, yeah. Maximum, that means we should fill all the levels. Okay, fill all the levels. All the levels must be filled. Okay, yeah. H, that means it is a complete binary tree. This case is a complete binary tree. Then, can you write n in terms of h? Right, easily, right? Complete binary tree, you can write easily, yeah. If you are not sure, you can still try some small h numbers to find the rules. Yeah, yeah. I think you won't miss it. Okay, so if you do in this way, you won't miss it. Okay, yeah. So that is question number 15. Yeah, yeah, yeah. So the last thing, you try to answer this question for relatively small h. Okay, and see what rule do you get. Yeah. So then after you try 2 or 3 examples, so you can find the rule immediately. All right, yeah. So you will get your answer for in a general formula. Okay, yeah. Then let me go to the question number 25. Yeah. So this one a little challenging. This one I ask you to give the solution. Yeah. Well, yeah. Here, I think I like to have a little more space. Oh, yeah. Can I erase? Yeah. So let me erase the, the old thing. Yeah, because that old part, at this point, we do not feel, it's important. Yeah. So let me just quickly erase. So I need a little more space here. This part I cannot erase. Oh, yeah. Oh, good. Yeah, I can erase. Yeah, a little slow. Yeah. All right. Yeah. All right. Yeah. So the idea, we use the max heap structure here. Okay. Yeah. The values in the parent nodes, child nodes, so we know that kind of relationship. Yeah. With that in our mind, so let us draw. We need to draw all the possible max heaps with these 5. So when we start, yeah, let's fix the easier part first. Yeah. All right. So first, we know the 5 nodes should be arranged as a near complete binary tree, right? So all the levels are full except the last level. Last level, only 2 nodes. Okay, yeah. And we also know the maximum element. Oh, yeah, this one pretty annoying. Yeah. The maximum number of, maximum should be at the root. 5 is here. 5 fixed. Yeah. So another thing, we need to fix the minimum. So max is fixed. Then let's look at the minimum, location for the minimum. Minimum not fixed, but we know it must be one of the leaves. All right, yeah, leaf node. Based on the max heap property, the minimum must be one of the leaves. Okay, yeah, one of the leaves in this diagram, we have 3 leaves, 1, 2, 3, 3 leaves. So that means the minimum can only be one of the 3 cases. Yeah. So case 1, yeah, let's say case 1 is here. Case 2 and case 3. Yeah. Yeah. Here it's quite confusing, right? Yeah. Let me try to use different way to write it. Yeah. All right. Case 1, let me use the square around it. Case 1. Case 2, 1 is in this location. Case 3, 1 is in this location. Okay. All right. So let me go on a few steps for case 1. Okay. All right. Case 1. Okay. Case 1. Case 1, let me draw smaller tree here. Yeah. And 1 is here, it is fixed. All right. 1 is here, it is fixed. All right. Then after 5 fixed, 1 fixed, we have only 3 remaining elements. 2, 3, 4. 2, 3, 4, we know 2 is the smallest, right? In the remaining 2, 3, 4, right? Yeah, 2 is the smallest. 2 is smallest, so that means 2 must be in one of the remaining 2 leaves. 2 must be in one of the remaining 2 leaves. Right? Yeah. So that means either this location or that location. Right? Yeah. So yeah. 2 possibilities. 2 possibilities. All right. Yeah. So then you have subcases. All right. Subcases. Yeah. Let's say, yeah, let me just do another one here. Subcase. Yeah. 1.1 subcase. All right. 1.1 subcase. So 2 in that location. So 5. 1 here, 2 here. All right. Yeah. So only 2 elements left. This is 1.1. Okay. 2 elements left. 3 or 4. Okay. 3 or 4. Yeah. 3 or 4. Can you try? Yeah. Yeah. Definitely we can put 3 here, right? 4 there. You check for violation. Is there any violation? No violation, right? Yeah. All right. But another question is, can you put 4 here, but 3 there? If you put there, is there any violation? Right? Yeah. Yeah. So that's the 1.1 case. All right. So let me do another one. 1.2 case. 1.2 case. So 5 here. Yeah. 5 there. We know 1 here and a 2 here, right? Yeah. 1.2. 2 should be here. Okay. Yeah. So then these 2 locations we need to, arrange 3 and 4, right? These two locations, 3 smaller than 4, so it looks like 3 should be here, 4 should be in the parent location, right? And you cannot switch, right? You cannot put 3 at a parent location and put 4 at a leave location. So it's different from 1.1. So 1.2 only one possibility. All right? Yeah. 1.1, you have 2 possibilities. Okay, 2 possibilities. Yeah. So here I use, this is the case 1, all right? Can you do the similar work for case 2 and a similar work for case 3? Then you get all the answers. Here, I did case 1 for you, okay? So you use my analysis logic. In case 1, you complete the remaining 2 cases, case number 2 and case number 3. How about that? Okay, so I leave some work to you. Okay, yeah. So I use case 1 as example. So you should, complete case 1 like this way. Okay, yeah. All right, so that's this question. Yeah. Then let me move to overflow question. Overflow, all right, yeah. Overflow, yeah. So I think I need to, let me think, do I have some, blank pages I can use to explain. Yeah. All right, so let me try to get a blank slide so I can use to explain that overflow question. Okay. All right, so this one with, I copied that slide. Yeah. But let me just remove the old handwriting. Yeah, so I get a blank slide. Yeah, let me use this one to explain that overflow problem. Okay. Overflow problem, based on the description, we need to use 2 ways to do detection, right? 2 ways to do detection. The first way, math formula way. Any of you have question on this step? Yeah, because last time I didn't show you the math. Yeah, a long time ago, I explained the method, math formula way. Yeah, so we start from Fibonacci number formula. Yeah. So let me leave it there. So later, if you need me go to that part, I can do it. Yeah, math formula way. And second, yeah, let me call it CS way. Yeah, math way and a CS way. Okay, yeah. So for the CS way, in my long time ago, I mentioned one method. Yeah, actually, one student tested and told me something not quite right. Yeah. All right. So, and math way, actually at that time, I also mentioned two ways. Yeah. So one way, for example, we do, yeah, we do C equals A plus B. Yeah. Fibonacci number, two smaller Fibonacci number, two adjacent Fibonacci number adding together. So we get a new one, and this could cause some error, right? Yeah, cause some error. So how do we check it? Yeah, let's say this, if this equals to C0, yeah, so yeah, I use A0, yeah, but basically the same. So we compare C0 minus A equal to B or not. Yeah, and this method actually, after that student told me, I tested by myself. I found a problem. Okay, the reason is even if this C0 is wrong, because of overflow, it is wrong. It is wrong. That means when we use sign long, when we use the long integer, long, okay, that C0 could be negative. The C0 could be negative. We know Fibonacci number cannot be negative, right? But when you do testing, C0 is negative. When you do this check, it gives us true. That's strange. It gives us true. Okay? Yeah. So that part I do not understand. Why, even when C0 is negative, when we compare these two numbers, it gives us true. That means we cannot detect the overflow in this way. All right. So this way won't work. Okay. Yeah. Cross out. Yeah. So that probably the reason some students ask me, talk about this question another time. So we need to modify it. All right. So this algorithm, we need to modify it. Okay. Yeah. All right. Yeah. It won't work. All right. So the modification, because we observe the negative case, we know Fibonacci number cannot be negative. Yeah. So the modification is like this. Negative number check. All right. Yeah. We do this. Okay. All right. So if C, yeah, let's just use C. Yeah. Whatever C you get, C equals A plus B. If C less than 0, we know it's impossible, right? You can have the conclusion overflow occurs, yeah, because the reason is simple. Fibo cannot be negative. Okay, cannot be negative. And you may ask, yeah, some of the students, you may ask why it could be negative, right? Yeah, so let me explain why it could be negative. Yeah, that's very easy. Yeah, that part is very easy. We know long integer, here we consider using long integer. Long integer 64 bits to represent long integer, okay? 8 bytes. All right. Then, because we choose long, that means signed long, okay? Yeah. Long means signed long. Signed long. Signed long, the first bit, this is the sign bit. It is used as the sign bit. Sign bit, it means 0, 1, okay? 1 means it's a negative number. Negative number, sign bit. All right. Now, when you do C equals A plus B, all right? Yeah. A and B very close to overflow, okay? But not overflow yet, very close to overflow. So then we can imagine each has 63-bit value. Each has 63-bit value, but just before we hit that highest bit, 64-bit, all right? Now you add them up, you get a C, so it hit, this C hits the 64th bit the first time, okay? The first time. And you detect it, okay? Okay, so you use the negative property check, so you detect it, you catch it. So the first time it hit overflow, to make the sign bit 1, value 1, that means negative, and you use this property to catch it. All right, so in this way, you can catch that overflow phenomena. Okay, so that means you need to modify the old way to this way. Yeah, so that old way. Yeah, but that old way, based on my experience, yeah. Because I gave this problem before, but why no student complain about that? Yeah, that old way. Yeah. I can go back to check some of the my old submissions. Yeah, so I can check how those students did this part. Yeah, so if they use the first way to check it successfully. Yeah, based on what we did this semester, that method does not work. Yeah. All right. Yeah. Don't worry. Yeah. So because here we found the problem, so we should fix it. Okay. So don't worry. So we should change our overflow detection method. Okay. So use that negative way. Yeah. All right. Yeah. So that is, you use the signed long. But any of you, if any of the student, if you like to use unsigned long, I searched the web. I tried to find all the possible ways because I want to find the easiest way. So some way could be very complicated. So I don't want to go that far. So I found the easiest way is use big integer. Okay, use Java big integer. But question, how to use big integer to, to find the answer for unsigned 64-bit overflow? Yeah, because this class has the bit or bits. Yeah, I'm not sure. Yeah, length method can give us the number of bits. When this bit length method hit that 65 number, yeah, because for unsigned long 64, we do not treat as overflow. All right, yeah, because for unsigned long there is no signed bit. We use all bits to represent valid numbers, so there is no signed bit. So we can use all 64 bits. Yeah. But now overflow detection, we should use 65 to do detection. That's the overflow phenomenon place. Okay, yeah. So if some of you really like to consider unsigned long, this is the easiest way. Yeah. Other way, I found so not that easy. Easiest way. Okay, yeah. So this way, very simple, very easy. Yeah, because we want to find the answer. So it is okay. Yeah, it is okay. Yeah. All right. Yeah. So that's the answer of this question. Any more question? Yeah. Implement both method. Right. Both. What I mean, what do you mean both? Both, that is math way, that is one, and the CS way, another. That's the both. All right. I do not mean both signed long, unsigned long. That both not, yeah. Both means the first way is the math formula way. Second way, the CS way. CS way, you only need to do one way. All right. CS way, you do not need to do two ways, two different ways. Okay. So CS way, yeah, that negative, that way, yeah, that is fine. Yeah. Or any of you, if you choose big integer, bit length way, yeah, you only need to do one of the two. Yeah. Math way. Yeah. Math way, do you feel comfortable doing the math way? Yeah. Do you feel so? Yeah, okay. Math way, when we use the formula, we use double, right? Yeah, the power function double to do calculation. Flow function, logarithm, all that calculation, we use double. Double, we know that when we use those function, power function, log function, the parameters all in value double, then you can handle computation much larger than the integer overflow one. So when you do calculation integer, for that integer overflow, but you pass the numbers as double for those functions, double, you won't get overflow. Yeah, because double can handle much larger numbers. So you just plug in, the maximum, yeah, let's say the maximum long integer number, yeah, maximum long integer number, you can get that value, you pass that value to that, power function or log function, it's within the value, the range. So I didn't do the calculation myself, yeah, but I can check it. I can do it by myself. Okay, yeah. Any of you who has done math formula way and got it correct, you can let me know, because I didn't get any response related to math formula way. Yeah, yeah. But today I can do it by myself. Yeah, and I can let you know what my running result. Yeah, yeah. So if any of you gets any problem, yeah, math formula way, yeah, you can let me know. Yeah, I think we should not have any problem. Yeah, we just find, you know, appropriate math functions. Yeah, basically two functions we need to use: double function, power function, yeah, power function, and logarithm, log function. Yeah, so then we do, you know, plug in into the formulas and take floor function, ceiling function. Yeah, so I'm not sure. I need to check the original formula, floor function or ceiling function. We get an integer and see if it is the same as our CS way. Yeah, CS way, we have an answer, right? 92 for unsine and then 93 for sine. So CS way, we know those two numbers. Yeah. So we just compare if the math formula way can give us the same answer. Okay. Yeah. All right. So that's you know, so if you feel all right, so you just, you know, work in this way. Okay. Yeah. Any other questions? We only have about 10 minutes left. Yeah. Turn in doc. Oh, don't turn in doc class file. Oh, yeah. Cardi, right. Don't turn in. Yeah. About. Okay. All right. Two questions. Yeah. First, doc class, because I need to look at your source file. Submit. Yeah. Entire project. That's not important. The most important is the source file, your Java files. Because the class file, I cannot read your code. Okay, I cannot read your code. Yeah, resubmit with all. Yeah. If so, first, yeah, for your question, colleague, for your question. So if your class file is not, if your Java file is not in your project folder, then you need to resubmit your Java files. Okay, yeah. So resubmit the whole project or not. So I only need your Java files. Okay, if you didn't provide it the first time, so you need to provide it. Okay, all right. Another question about like ask final exam. Post yeah, all right, good. Yeah, question, how long? Yeah, give, good. Yeah, does cover hashing. All right, yeah. Yeah, so it's a good question. Yeah, for final. For final, remember our final. Yeah, I like to run. Yeah, I don't know if I talk about that or not. Yeah, yeah. One quiz 5 and one final. Quiz 5, as usual, we have 10 questions. Final, I do reduction, all right? Yeah, because you already have quiz 5 questions. Reduction, so I make 15 questions here. All right. Then for your question, Sylvia, because you're asking about hashing, right? Yeah, hashing, I put some hashing questions in quiz 5, okay? Yeah, I only put hashing questions in quiz 5. And in the final 15 questions, I won't put any hashing questions. All right. The final 15 questions, I only use the same type of questions in your homework assignment number 2. Yeah. So these 15 questions, the question type will be, very close to homework assignment number 2. So no hashing questions. All right. Yeah, but quiz number 5, I may put, let me see, 1/2 hashing questions. How about that? Yeah. 5 of the 10 questions, some basic facts about hashing. All right. The remaining 5 still, in the coverage of homework assignment number 2. Yeah. Homework number 2. So 5 plus 5. Yeah. All right. So, then the time, right? Yeah. Sylvia also asked me how long, when post and how long. Yeah. All right. Post, I like to post it December 13, Tuesday. Okay. December 13, Tuesday. All right. And so that's the final. All right. The due date, Tuesday, Wednesday, Thursday. Yeah. Let me put Friday. How about that? Yeah. The due date I give you December. Yeah. So 14, 15, 16, right? 16th Friday as the due date. Yeah. 15 questions. Okay. Yeah. 15 questions. So online. Yeah. So you do online submission. Yeah. Yeah. And quiz 5, I will post a few days earlier than final. Okay. Quiz 5, I give you 1 week. As our usual quiz 5, our usual quiz setting. Yeah. I give you 1 week. Okay. And there is overlap with this. There is overlap. Okay. Yeah. Yeah. A few days earlier, a few days after, there is a 1 week period for quiz 5, 10 questions. Yeah. Yeah. So that's pretty much, my plan. Okay. Yeah. I will post this kind of plan because there are many other students who do not show up today, and I believe quite some students they may not watch this video, so they may not know this information. So I will post the final and the quiz 5 information as announcements. Okay, for 2 class sessions. Yeah. All right. Oh, yeah.